G'day, I'm Glenn Morris from the Smart Energy Lab, and today in the lab I've got Thomas Bell from Sunman. G'day Thomas.
Morning Glenn, how are you?
Yeah, good. How'd you go getting up here from the airport?
Lovely. Flew in last night, a little bit of a rain delay at that Sydney airport, but other than that, in and nice and snug last night.
Your baggage come with you?
It did. I did. I borrowed the wife's bag, a nice big pink one, so easy to stand out.
So you're actually here for All Energy, which starts this week.
Yes, very excited. First time we've been at All Energy now for a few years with coming out of COVID. So Sunman is very excited to be participating this year and promoting our technology to the broader PV industry.
Yeah, cool. Now, I often like to start these chats with a bit about yourself and, like your career path, how you came to be. What's your title, by the way?
I'm the sales director at Sunman in Australia.
Okay, wow. You're the man. So how did you come to this position?
My first job out of high school was in the insulation industry back in the late 90s, where I learnt for the first time that Australia has very inefficient infrastructure from electrical and thermal heating and cooling. And that really developed my passion for what can we do to make Aussie homes and constructions more energy efficient. And that naturally then drew me to the solar industry in 2008. So at that time, I believe there's 400 homes with solar. And it was really in its infancy.
Yeah.
Just jumped on the solar coaster back then and managed to grow with the industry to where I am today. Again, particularly with my role at Sunman, being on the forefront of new technology. And I think that's what excites me about solar, and particularly the work that people like you do is pushing the industry in terms of what can we do to do things better, more efficient, and ultimately deliver more value to our customers.
Yeah, right. So, I didn't realise that. So, the insulation industry back in the late 90s, are we talking like pink bats?
Yeah.
You're probably lucky you weren't during the pink bat debacle.
Not the debacle in the mid 2000s. No, well before that. It was at the same time that the government, I think it was in New South Wales, introduced the NatHERS, National Home Energy Rating scheme. And just like when you bought an electrical appliance, there was a sticker that had many stars, and that was the first time that a home actually had to meet a energy efficiency level. So builders were forced to, build things not to the lowest bottom line, but to make sure things were energy efficient. And 30% of a home's energy bill is directly related to heating and cooling. So insulation was a simple, cost-effective way for many homeowners and builders to start their journey to efficiency. And that's also led on to solar photovoltaics. Is typically now when people buy a home, one of the first questions they ask is, darling, how much is it going to cost us to live here? What's the utility bills going to be like? So double glazing, LED lighting, effectively insulated, solar and storage are all high on the agenda now as the people looking to build new homes. So back in the late 90s, that's where I cut my teeth, and that's sort of where I am today.
Yeah, so look, insulation is kind of the poor relation of sustainability. Everyone goes, solar panels is where it's at. But actually, I think always talking to the public, I say deal with the thermal issues first if you can, and particularly if you're building a home. That's where the biggest savings are.
Yeah.
And solar is really the icing on the cake. It's the generation. It's the free energy to cover what the house needs. You don't want the house to need a lot. You want it to need a lot.
I use a similar analogy. I think of energy efficiency and generation as karate. You don't go straight to black belt, and PV and solar is black belt. What is the green, yellow, blue? What are the steps you move up to energy generation?
I like that analogy. So solar installers are black belt electricians.
That's it. And the cheaper solar is the solar you don't have to buy. So,
that's right. The negawatts.
So doing doing simple things, insulation, glazing, door seals, zoning off rooms, all those things that feel small and insignificant do really do add up.
I mean, it is a bit of a shame that the NABERS and other rating schemes are so low, like 5 stars, 5-star plus. It's probably the bottom of the developed world.
Yeah.
You go to Europe and that you'd be illegal to build a house like we build.
Yeah.
In Europe, it's got to be 7 stars, 8 stars.
Yeah.
Double glazing. Visited friends in Europe, and double glazing's almost unheard of. It's triple glazing.
Yeah.
And you go, well, it makes sense.
Yeah.
Here it's kind of expensive because we just don't incentivize it.
Yeah.
But once you've got a market for it, the price comes down, and suddenly your house is comfortable winter, easy to heat and cool.
Yeah.
Yeah, big plus.
Well, I mean, that's, as homes' energy storage is still in that, let's face it, early adopter stage, if your home's well insulated, well, you don't need a battery. You can use the air conditioner as a battery. So you pack the kids off to school. It's going to be 42 degrees today.
Yeah.
Bunker down the home. Set the aircon to turn on to 26 degrees at 1 o'clock, and you slowly bring your home up to temperature using the power of the sun, and that effective is a way of storing energy in coolth. So,
yeah, absolutely. I mean, if you've got thermal mass in a building, it's a battery.
Yeah,
it's an energy battery, whether it's coolth or warmth, whichever you want to store. Yeah. I love the word coolth. No one ever hears it much because it sounds so old-fashioned. But us in the energy industry know about coolth.
Yeah.
It's really cool. So, Sunman, look, you've got a rather famous, what shall we call his role?
Dr. Zhengrong Shi is the CEO and founder of Sunman. So, solar pioneer. Quick backstory: moved to Australia. Well, Dr. Shi moved to Australia in the 80s. Studied under Martin Green at University of New South Wales. Worked at an Australian solar company called Pacific Solar back in the 90s, developing technology called crystalline silicon on glass. And then in the late 90s, the Germans created the world's first feed-in tariff and created the world's first global market. So Dr. Shi saw an opportunity that PV is looking to become a mainstream product. Wasn't able to get local support here to further develop the PV industry. Packed up his family and went back to China and set up Suntech, China's first solar cell manufacturer. And then by 2000, I think 9, 10, 11 was the world's largest manufacturer of products, of solar modules. So being a serial entrepreneur and passionate about photovoltaics and the energy transition, has done it all again and set up a new factory called Sunman, where he's developed the world's first IEC certified lightweight glassless panels. And the motive for this product development, Australia is a bit of an anomaly globally in terms of PV industry. The rest of the world went to utility scale first. Australia went to rooftop first. So many of the or the global market for rooftop is still in its infancy. So I guess the main focus for Sunman is developing a module that's been specifically designed for rooftops. Whereas in Australia we take utility scale panels and try and shoehorn them on a roof. Further to that development, we estimate that approximately 40% of the commercial industrial buildings globally, when they were built 5, 10, 15 years ago, aren't engineered to take the weight or uplift of a conventional glass panel system. So as our rooftop market matures, the goal of getting full rooftop utilisation becomes even bigger. So the structural limitations that come with conventional glass panels do provide a hurdle or stop that from happening. Furthermore, with changes to AS 1170 2021, that's going to put even more pressure on the use of conventional glass panels by reducing the usable area as we get closer to the edges, significantly increasing fixing points and the use of 3 and 4 lengths of rail.
Yeah, now we talked about this before we started recording, and I hadn't actually realised the implications. Apologies to my audience, but 1170.2 is not my strength. I'm more on the PV side and the battery, but yeah, that's right. But it's really for structural engineers,
yes.
And it's about wind actions. Now, 1170.2, the latest version, 2021. I don't think it comes into force till May next year.
I believe so, yeah.
And it's significantly strengthened up. Once again, excuse the pun, the requirements for fixings for PV systems.
Yeah.
And that's the point you're making, that conventional rail-based systems are going to suffer from this.
Yes, that's going to reduce their usable area, and in the areas that they still can use, it will add extra cost in terms of more mounting requirements, be that clip lock clamps or L feet, and potentially 3, 4, and 5 lots of rail on those sort of edges.
Wow.
Closer to the
It's a lot of aluminium.
Yes.
Right. Yeah.
More labour, more work. So. Again, Sunman brings that solution to the market.
Now, we've talked about Sunman as a company, but we haven't talked about the actual product. I think we probably should just lay one out here on the table, shall we?
Yeah, let's go.
Okay, let's do that. Look at that. Wow. I can see what you mean about rail-based systems. There's no need for rails on this.
Yep.
So should we take all the packaging off? That is what I call low profile. Wow, that's incredible. And all our junction boxes are on the top here.
That's right.
So there's no lying on the hot tin roof without a fiddle and trying to make all the connections underneath.
That's right.
How do you earth a panel like this?
Because our panels have no metal parts, the array needs no earthing.
So it's got no metal parts, so that's one less hassle. And actually, when it comes to commercial, under the new 5033, earthing is becoming a bit of a problem with big systems. You're talking 35mm earths up onto the array, and what do you attach that massive cable to? Mm-hmm. Here, there's one less cable, less cost, less hassle. But I'm still curious, how do we attach this to a roof?
So we use a structural grade silicon adhesive to bond the panels to the roof. So we have 2 brands of silicon available in the Australian market. One is called Tonsun. Tonsun supply 80% of the silicon used in the conventional glass module manufacturers. It's the white silicon that you see on the back of a glass panel that bonds the frame to the glass, and it's also used to pot the junction box.
Right, so this stuff here?
That stuff there.
Oh my gosh, okay, so if this is warranted for however long?
25 years.
25 years. The same material here is also what you bond to the roof with.
That's right.
And it's also out of the sun. So
out of the sun.
Yeah, which is the main problem.
We also have another brand of silicon manufactured by Sika. They're the world's largest chemical construction company, and they have a product called SG20, and that's used in the glazing industry. So think about your car windscreen is glued into the steel frame, and your multi-story buildings, the glass curtain walls are also glued into place. So the technology that we use to bond is old technology and has been used for many decades. So bonding solar panels to a roof.
When cars are glued together.
Bonding solar panels to the roof to the average commercial installer or to the average commercial owner may seem insufficient, but in terms of chemical engineering and bonding, it's pretty low tech to what other things we do in the world with adhesives.
Also, it's incredibly low profile. We're not talking 150 mils off the roof.
Well, that's one of the angles that we solve, particularly in the residential market. In 2016, we raised some money from Arena to help further commercialise the technology. And at that time, we identified that 25% of the residential market would never buy solar because they perceive it to be ugly. So being able to bond solar panels to the roof creates the illusion of integration, because when you stand up at street level and you look up at the array, because you don't have that sort of 200 gap off the roof, there's no line, so it creates that illusion of integration.
So Thomas, I just got a bit of tin out from the back there and thought we'd show how it actually attached. I mean, what we've got here is some standard clip lock, and the surface here. What would you do to prepare for installing one of these panels?
So the standard installation method is, number one, mark the roof.
Yep.
In a quick bonding or Sunman installation, because there is an element of cleaning the roof, it is really important that we mark the roof out properly to really minimise, work down the path. So step one, mark the roof. Some people use string lines, some people use chalk lines, some people use a Sharpie. Every tradesperson has their own process to marking the roof. Whatever that process is, be able to mark out which ribs you're bonding to. We do have some overhang requirements, so you need to know where your first panel is starting, where that overhang is, and sort of map that through the array. So typically, the project lead and the right-hand man within sort of that hour or so have gone through the roof and marked it up, so we know where panels are going and where the glue needs to be applied. So step one, mark the roof. Now that the roof has been marked and we know what ribs we're bonding to, we clean the rib with an alcohol solution. Just like when you go to get a needle, the doctor gives you a little alcoholic rub, make sure the area is clean. No different to that. So we clean the surface. The process that seems to be working at the moment, we get a weed sprayer, backpack, little nozzle. One guy sprays it with the alcohol, and then we have another person behind with a microfiber cloth, just cleaning the surface, so creating that sort of production line process. And then once the area has been cleaned, a necessary tool for our technology is a automatic caulking gun. So whatever tools the team use, each of the major brands also have an automatic caulking gun, so where you can put your silicon sausage into the gun, press the trigger, and it comes out at a controlled method.
Otherwise, you'd be getting cramps by the end of the first before morning tea.
And not to mention the efficiency with those guns, you can sort of get a rhythm.
So you lay a bead of your bonding agent, this white stuff, onto here,
onto the top of the rib. Yep.
And how long can you leave it there before you have to attach the panel?
Yeah. So like any adhesive, it depends on the time of day, temperature, humidity. So pay attention to the weather conditions of the day, but generally speaking, you've probably got 3 to 4 minutes before a skin forms over.
So you don't want to do the whole roof, cork the whole roof, and then start putting panels on. You want to, as you go, cork panel.
Yeah, when I train installers how to install Sunman, I don't need to tell them how to be solar installers. I mean, that's your job. I'm just teaching them a new method. Another analogy, if I go from Android to Apple phone, my brain has a meltdown trying to understand new systems. So same with solar installers. They've been doing glass panels for 15 years and they get up on the roof and they just, where do I start? So
with Sunman, they wonder why they haven't got a sore back at the end of the day.
Yes.
Well, what's wrong? I'm not feeling exhausted.
So it's more about just teaching the methodology. And I mean, speaking in analogies, we're sort of laying bricks now. So you've got one person bringing the bricks up, you've got one person bringing the mud, the panels, the glue, and you've got one person two people laying the panels, and you sort of
Yep.
just create that production line.
Yeah.
Production line
So
process.
let's do this. We've put our caulking compound down on in this case 3
Yep.
ribs.
Two people.
We've already marked
Yep.
where the top line is,
Yep.
and we just plonk it down.
Plonk it down.
Do we have to press it?
Yeah, so every roof is never 100% square, so we can use a paint roller.
Oh yeah.
So you don't want to press it too hard that the glue comes out like melted cheese,
Yep.
but you want a gentle kiss to ensure that we have contact between the glue and the panel and the roof. So it's more just a gentle press with your hand or with a
paint roller.
with a scale, with a little paint roller. So
All right.
so the ideal crew to lay these panels is sort of a team of 4. So you have 2 boys. You've marked. 2 people are marking the roof.
Boys or women? Yes.
Yes, crews. You have installation crews.
Yep.
Ideal number is 4, and we'll bring up the women installers later on, because I think our technology will sort of expand the labour pool because of constraints around such heavy panels. But yes, thank you for picking me up. So ideal crew is 4. So you have 2 people starting to mark the roof. And then you have the other 2 crew get panels in position. This is roughly where the string's going to go. Lay all your panels out in a pattern. Have a tube of silicon all lined up. They clean the roof, the string. The rest of the roof's been marked, and then it's a process of 1 person on the gun laying the glue, the adhesive. 2 people. Because the panels are quite large and they're 1 metre by 2 metres.
Yeah, should point out this is like your camping panel.
Yeah, this is just a demonstration panel, just so we can sit on the table.
Yeah.
But it would scale up to 144 cell, 430 watt equivalent.
So at the moment, your dominant size is the 430 watt
430
module.
is our go-to market.
What are the dimensions?
It's roughly 1.1 by 2.1 metres.
Now, in terms of handling these, they are, we try to avoid the word, but they are a little bit flexible, right? But you don't want to adversely point load them.
Yes.
So when you're picking this up, 2 people?
Ideally, you would.
Look at that, it's so stiff.
You want 2 people.
Yep.
And to avoid, so the panels are, sort of semi-flexible. They're designed to be rough and ready to be handled on a construction site, but we just have to be a little bit more mindful around, just grabbing the panel with 1 hand because they're so light.
Yeah.
It's just easy enough for you to just grab it with 1 hand and put point load.
You gave the analogy to me before of plasterboard.
Yes.
Right? So gyprock. You don't want to pick it up by 1 corner.
Yeah, so-
a big sheet of gyprock that snaps off.
Because it's light, it gives the illusion that you can get away with handling it with 1 hand. So it does need 2 people to handle it, and just being mindful of when you are picking it up, where that load is positioned to avoid touching the cell. So there's plenty of white space around the modules to effectively grab.
Okay, so we've got them glued down, so we'll just put them back in position. Now, the connections are on the top, which is, to me, a big plus in terms of ease of access to all the terminations and plugs, but how do we secure the cabling?
Yes. So with our Grid Connect panel for the Australian market, we've designed what we call a duct box. So there's a plastic fitted at the factory. There's a plastic cover that sits over the junction box. For the 430 watt panels, the junction boxes are on the longer edge.
Yeah.
And then there's a duct box that clips into place. And that duct box has been designed to, one, encase the DC cable, but also provide a space for 2 additional cables for string return runs.
Right, so your home run cable's inside that duct box as
That's
well,
right.
up to 2 of them.
Yeah.
There's no exposed cables to sunlight.
No.
In fact, even your junction boxes are then covered as well.
Everything is covered up. So
And it's all pretty low profile?
all low profile. The junction boxes, I believe, are 14 mm high.
Yeah.
We can clarify that with the data sheet, but it's about that 14 to 16 mil.
Very neat. And if you need to access any of the connections for testing, you can just lift the duct box off again?
That's right.
Right.
Junction box just slides off.
Oh, that's really nice. Now, this is a clip lock roof, so there's no screws visible, but what about if there were screws sticking up here? What do we do then? Yeah,
so when we do our quick bonding method, we're unable to bond over existing roofing screws. Roofing screws tend to have a head that's 12 to 15 mil high and protrudes and may point a point load on the back of the module. So from a residential situation, most of the battens are typically 6 to 900 mm apart. So for our residential market, to improve the aesthetics of the installation, you'll need to use a screw. We've developed a screw with a company called Buildex, who are Australia's largest roofing screw supplier. So it has a 3 mm head on that. So when you apply your bead of silicon of 5 to 8 mil, it provides a surface for us to easily bond over the screws.
Right. So you take out the existing hex head screw, put in a flathead screw.
That's right.
Which you provide.
We provide.
Which is the same physical dimensions, like 75 mil long, 50 mil, something like that. And that means that it's now got the same profile as the bonding agent, so it doesn't create a point loading.
That's right.
Okay.
So residential market for screw down metal roofs, we to maximise rooftop utilisation and to get the best aesthetic look, there will be a screw replacement, typically 4 to 6 screws per panel. So again, nothing too outrageous. In a commercial application that has a screw down metal roof, we can get a bit creative with the array, particularly if your panel, the purlin spacings are 1500 apart. We can put some photos up on the screen where the panels are butted together right next to that screw, so you've just got that gap.
Yep.
And then every 2 rows of panels, we'd like to have a walkway so you can easily access your cable management.
Yep.
So in those circumstances, we don't need to replace the screws to maintain full rooftop utilisation. But as we get closer to the edges of buildings, the purlin spacings can get a little bit closer. So there may be some parts of a commercial roof where you may need to replace some of those screws to maximise, again, full rooftop utilisation, which is sort of the main, sort of the core drive for Sunman's competitive advantage.
Now, one of the key things I notice about these panels is they're lightweight, right?
Yes.
But also they're frameless.
Yes.
Now, if you're installing panels flat on a roof using conventional frame modules, one of the big problems is keeping them clean, because they've effectively got a little dam wall so that dust and dirt can't drain off the side. What's going to happen here?
I think you've answered your own question. There's nothing to stop and build up that dirt and debris. Most of the commercial roofs, 2 to 4 degree pitch, so enough for self-cleaning, but nothing for dirt, and no lips for the debris of dust and stuff that will build up over time.
If you do need to clean these, what would be the methodology?
Well, you would use the same methodology as a conventional glass module. Avoid detergents and solvents where possible. Use a dry brush to brush off debris, or a small amount of water for some of those more stubborn stains. Right.
Okay, so the fact that they're more self-cleaning, let's say it not perfectly, but more self-cleaning than a framed module. If we look at the environmental impact of solar panels, there's a lot of criticism about the embodied energy in a solar panel, and it's actually pretty small. But mostly it's glass and aluminium. They're missing from this. There must be very little embodied energy in one of these panels.
Yes. So, glass and aluminium are 2 of our civilization's most energy-intensive products. So by removing them completely from a manufacturing process does give us a significant advantage in terms of embedded energy. If we take that one step further, our packing density is significantly more. So the carbon footprint in terms of freight is also significantly reduced.
So you were saying to me it's something like 30 kilowatts on a pallet?
So in our 430 watt range panels, there's 30 kilowatts, 28.9
in a standard pallet.
in a standard pallet.
That's crazy. 30 kilowatts.
Yeah.
Right.
Yeah. You mean think about the soft cost savings: less crane lift, less edge protection hire, less transport. Don't have to trucks with high abs. If I'm a rural installer, 2 pallets on the back of the ute now is 60 kilowatts. So there are all those soft cost savings that can help get a project up.
Now, coming back to the environmental cred, the other big issue is end of life of solar panels, and in this state, Victoria, it's considered e-waste, so you can't put it into the waste stream. There are a few companies, in fact, I've interviewed them on this channel before, who do solar panel recycling, and they just munch them up basically. But it's glass and aluminium. They've got to separate those materials so they can be separately recycled. I imagine these would be pretty easy to recycle. Yeah,
so we would take a similar path to that of a conventional panel. Another analogy is think about this front sheet just like the EVA of a conventional glass panel. So when you remove the glass and aluminium, you still have your cells encapsulated in a plastic EVA material. So the panels would enter that stream and then go through that same recycling process.
And in terms of cost, the companies I've looked at, they charge per kilo for recycling at the moment.
Okay.
And so, a typical panel weighing nearly 20 kilos, and something similar sized from you would be what? Proportionally, how much lighter?
So our 430 watt panel weighs 7 kilos. Equivalent would weigh sort of 25 kilos.
Right, okay, wow. So better than 3 times lighter, better than 3 times cheaper to recycle just on weight.
Well, hopefully we won't have to recycle any panels soon.
No. What is the warranty on this?
So the product comes with a 12-year product warranty and a 25-year linear power warranty.
Okay, to what percentage?
So year 25 is 83.1%.
All right, so standard industry profile.
So this is coming back to the Dr. Shi story.
Yeah.
Dr. Shi hasn't innovated the cells. Monocrystalline silicon solar cells, proven, tested, reliable, durable. There's enough empirical data out there that these are the best semiconductors for photovoltaic. So we don't make our own cells. We OEM our cells. Really what we are is a material science company where we've developed a composite material that has the same strength and durability of glass, that's able to pass the IEC 61215 certifications, the same standards that glass panels must. So our IP and technology is in this material. So in terms of the cells themselves, they're just the
your standard cells. Are they N-type or P-type?
At the moment, these are N-type.
Right. Okay. Yeah, so half-cut N-type. The half-cut cell arrangements are similar with glass panels, where you've effectively got like 6 sub-modules within a frame, so that you get more shade tolerance.
That's right. So in our 430 watt panels, we have 3 bypass diodes.
Yep.
So the panels are wired up into the thirds.
All right.
But we come this way.
Yep.
For that, so they still have that built-in shade tolerance there.
Can these be installed in any orientation, like landscape, portrait?
Landscape, portrait,
as you wish.
As you wish, depending
diagonal.
Write your factory name on the roof. Yeah, there's no as long as we get the bonding area that we require.
Yeah, it's funny you mentioned write your name, because actually I did a design for a company who wanted their name on the roof.
Okay.
And it's funny doing it with pixels as big as panels.
Yeah.
It's actually quite challenging.
Yeah.
So just the surface texture, what's this about?
Yeah, so we the laminating process puts this texturing on top of the module, and that's to help capture more light, because typically our installations will always be flat.
Yeah.
So the textured surface will help to reflect more light back onto the cells.
So it's like the little pyramids that are also etched onto the cell.
Yeah.
It's little pyramids, effectively, that angle light coming at an oblique angle is then reflected onto the cell.
Reflected onto the cell. Also, no cell is 100% absorbent. Some light is still lost in reflection from the cell. So again, if it hits the bottom of the pyramid, it's there to help squeeze a little bit more energy out of those photons.
Yeah. So I guess what you've got here is a product that solves problems for many installations.
That's right, and I think that's the exciting part of working with Sunman and Dr. Shi. It's we're trying to move the market forward in terms of helping deploy more solar on applications where conventional solar can't fit. So full rooftop utilization. How do we get more panels in load centres? Why does a solar farm have to be built at the back of Wagga Wagga or Ballarat, 600 k's away from a load centre, transmission and marginal loss factors? Why can't we turn our industrial parks into solar farms where we can have in front and behind the meter opportunities? So full rooftop utilisation. Walls. If I've got a factory that's 100 metres long, 16 metres tall, facing north, why can't I stick them to the wall?
I'm a big fan of wall-mounted solar. I've got a lot here around the lab because it's actually really convenient to show people solar panels. But in the afternoon, the sun's at a low angle and there's still heavy load, especially in summer.
Yeah,
a wall's actually a very viable option.
Some of the high-level analysis that we've done, if I have these are Sydney numbers. If I have a wall on facing north in Sydney, it'll produce about 2.7 per kilowatt hours per kilowatt peak. East and west is around 2.2 kilowatt hours per kilowatt peak. So it's really not that much of a drop off if we can make it cost effective to install. But the real benefit for wall installations from our analysis is winter. In July, we can get 4 kilowatt hours per kilowatt peak.
Because the low angle of the sun.
The low angle of the sun. So in those load profiles where you look at the interval data and the rooftop system's not, helping us too much in summer, getting them on the walls to sort of, kick up generation during those winter months, again, is another way of tackling that load profile outside those peak generation months.
So you actually make it easier to cover almost every part of a structure with solar panels. you can go for the easy parts, the flat roof, but then you can do all the tricky parts, the walls and things. Wow, that's a real plus.
So just on that point, I think it's we encourage installers not to or end clients not to feel I can only put one brand of solar panels on the roof. If your roof can take glass panels, put glass panels down. But where they can't install glass panels, have a combination of. Because again, our mantra is full rooftop utilisation. Many of the large-scale commercial inverters now, 6-9 MPPT. So there's technically nothing stopping us from mixing and matching panels on that roof. We were a part of a project last year for Sydney Olympic Park Aquatic Centre. Where it's
got a bit of a curve, hasn't it?
It does have a bit of a curve. But the main learning outcome from this installation was the roof could take 1.5 megawatts. The customer really wanted 1.5 megawatts, but due to structural limitations, they were only able to put 750 kilowatts on. So it sort of really reduced the... what's the point? We were only sort of...
You mean using conventional glass modules? Yeah,
using conventional glass panels. So Sunman, in conjunction with glass panels, we're now able to put glass panels where you can, and where you can't, we, again, full rooftop utilisation. So now we help the client cover every square centimetre of their roof. Being a swimming pool, very high load profile, so every kilowatt hour is mostly needed.
So you could also slightly curve these too.
Yes, the panels are semi-flexible. So we have our two most iconic curved roof projects at the moment. One is Sydney Olympic Park, and the second one is Noosaville Library that we did a couple of years ago to meet architectural constraints, because the architect didn't want the glass panels sort of looking sort of a bit
faceted,
a bit clunky as they come down the roof. So
just kind of what my house looks like, faceted on a curved roof. Yeah. All right. Wow. So have I missed anything?
So I think back to the labour part. And occupational health and safety, I think let's not overlook these parts. We're struggling for labour at the moment, and I hear from many installation crews that retaining labour is quite hard. Little Johnny or little Jane thinks, I want to be a solar installer. Most of us, we always have to start at the bottom, and the bottom is lugging panels across a roof all day and every day, and it becomes quite tiring and taxing. And we do lose a lot of labour just because of that, how hard the work is in distributing panels. So again, having lightweight panels could be a way of keeping and retaining staff. If not, helping double the labour pool by encouraging more female installers to come on board. Not to mention any benefits around occupational health and safety. Backs and elbows, and walking on a roof's difficult. It's not like you've got a flat surface. You're always jumping from rib to rib, trying not to stand on a rib and put a divot
or trip over a rail.
So I think the market's yet to sort of digest those other softer advantages. Like most things, there's a learning curve that needs to get down. So, I'll train the installer base on how to install solar. I can't expect after, a couple of hours of training that they're at Olympic pace. So it's going to take some time to get down for the crew to learn their installation methodology. We're doing a job for a large pharmaceutical company in Mulgrave. Day one, stock was delivered. By lunchtime, the roof was marked out, and that afternoon, they laid 30 kilowatts. So, on a 500 kilowatt project, day one, panels are down.
That's impressive. So it's the speed of installation.
Speed of installation is we'll get there. What we're seeing in more advanced markets like China and Europe. We're seeing sort of 30 to 40% less time on roof.
Right.
So when you get up to 600-700 kilowatt systems, that labour saving becomes very meaningful. Not to mention crane lift higher, edge protection higher. And all the other soft costs.
Are there any training resources if you want to learn about installing these?
At the moment, we're in the process of preparing a formal training program. But at the moment, as new installers come into the fold, Sunman will do a one-on-one training session.
Oh, wow.
With each installer and help with some basic design, just to make sure that the array is optimised for installation. And help calculate, balance the system, and provide that high level insight. So contact Sunman for your first project, and go through your books over the last few years. What jobs did you have to walk away from or had structural limitations? As our market, as the global economy softens and the work becomes more competitive, it could be a good time to pivot the business to look for opportunities where somebody really wanted solar due to aesthetics, penetration, or structural limitations around weight or uplift. And that's another point that we've probably not put enough attention to. I think zero penetration.
Yeah, I just thought of that then. So if you've got a brand new building, the roof's under a warranty, you start just whacking holes in it, you effectively void the warranty.
Yes, but then we've also got concrete roofs. We've also have insulated panel roofs. We also have membrane roofs.
Yep.
So there's a high portion of roofs out there that just can't be penetrated.
Yeah.
Or ballast system just becomes too cost prohibitive. Furthermore, with ballast systems, once you sort of get up around 4 or 5 stories, ballast systems become.
You could probably ballast these with some bricks on the corners.
Glue's cheaper.
That's true. Way cheaper. Well, Thomas, look, it's been really fascinating learning about the Sunman lightweight panel. Look, I'm quite excited by this technology. I'd like to install some here at the lab, so I'm going to have a go with the caulking gun and see what I can do.
Okay, great.
Well, I'll catch up with you at All Energy.
Yeah,
and
looking forward
to see
it.
those big panels, the 430s.
Yeah, come and have a look. Get the 430 and lift it. It's I like to run this experiment with installers. When you go to a shopping centre and the escalator is not working and you go to step on it, your brain has a little fumble because you're programmed. The same as the panels. I go lift the panel and you can see them as they go to lift it. Their brain goes, it's going to be heavy, and they almost throw it through the roof. So come on by and have a play with a panel.
Okay, good one. Well, thanks for coming.
Great. Really, thanks for having me.
Good.